Hello, welcome back everybody. Welcome back to my channel Knowledgification. Today we'll be talking about matter and our surroundings from grade 9 NCERT. Let's look at what we're discussing today. Matter and the states of matter and the change of matter, evaporation and condensation, factors affecting evaporation, effect of pressure on matter, diffusion and Brownian motion, sublimation, effect of change of temperature, measurement of temperature, and boiling or melting point. Let's jump in. Anything that has mass and can occupy space is called matter. We've been hearing this definition since a really long time. We also know that there are three types of matter: solid, liquid, and gas. We all know what solid, liquid, and gas is. I hope we don't need to discuss too much on that. So, states of matter. Solid matter boasts particles tightly packed in a rigid lattice, rendering it with distant shape and volume. Liquids with particles more movable but still cohesive, conform to the shape of their container. Gases, meanwhile, embody boundless freedom with particles dispersed from unrestrained. So basically what I'm saying is that solid, the particles are tightly packed. In liquid, they are movable but take the shape of the container. But gases, they are allowed to move freely and they're highly compressible. Also, we should know that the particles of every matter are always in kinetic motion. That means that they're constantly moving about in their own place. That is only in solids, but they're constantly moving everywhere in liquids and gases. That's what makes liquids and gases flowable. Now let's discuss about the transformations of matters. Melting, freezing, evaporation, and condensation are the ways through which matter changes its form. So from solid to liquid we change through melting, and from liquid to gas we change through evaporation, and from gas to solid is deposition. Now this is what we know from a really long time. Do we know from solid to gas? Yes, that's sublimation. We will be discussing sublimation in later part of our video. Now let's discuss about evaporation and condensation. Evaporation is the process by which water turns into gaseous form without reaching the boiling point of the liquid. This happens in seas when water transforms into clouds by the process of condensation. You can see in this image, I have not drawn very well, that evaporation takes place within water or any kind of liquid which condenses in the air in the form of gas. Through condensation, the gaseous form again turns into liquid, and as we see that the clouds again turn into water and fall as rain from the sky. Evaporation mainly happens through the sun. The heat produced by the sun heats up the water on the surface, and the water starts evaporating. It's not that the middle of the water, like boiling, it just takes place on the surface of the water. Now let's talk about factors affecting evaporation. This is very easy. Factors affecting evaporation include surface area, temperature, humidity, and whims of speed. Together they dictate the pace at which liquids turn into gaseous form through the evaporation process. The sun is the main ingredient for evaporation in the seas, which causes clouds and rain and etc. etc. Now let's consider the effect of pressure on matter. Have you ever wondered why water boils at a different temperature when you're high up in the mountains compared to the sea level? It's because pressure plays a crucial role. Increasing pressure raises the boiling point of liquids, making it harder for the molecules to escape in the liquid phase. Conversely, decreasing pressure lowers the boiling point, facilitating the transition to the gas phase. That's all with pressure. Now let's go to diffusion and Brownian motion. Moving on to diffusion. Diffusion can be defined as the movement of molecules in a fluid form areas of high concentration to lower concentration areas. Diffusion is also a process of fundamental to our lives, everyday lives, whether it's aroma of freshly baked bread wafting through the air or the spreading of ink. Diffusion is at work. It's the natural tendency of particles to move from areas of high concentration to low areas of low concentration, resulting in a uniform distribution over time. Now let's talk about Brownian motion, a phenomenon first discovered by botanist Robert Brown in the early 19th century. Imagine tiny particles suspended in fluid, constantly jostling and moving about. This erratic motion, known as the Brownian motion, is caused by collisions with rapidly moving molecules of the surrounding medium, providing evidence for the existence of atoms and molecules. So we can define Brownian motion as Brownian motion as follows. Brownian motion refers to the random movement displayed by small particles that are suspended in fluids. Now let's talk about sublimation. Think of dried ice transforming directly into carbon dioxide gas without passing through the liquid phase. That's sublimation in action. So we can define sublimation as the process of liquid transforming into gas without the involvement of liquid is called a sublimation. I made a little error in the definition over there. It's a process where substance transitions from solid to a gas without becoming a liquid. An intriguing phenomenon observed in various substances under specific conditions, like ammonium chloride is transformed to ammonium vapors. So as you can see in the image, that's the process of sublimation done. Moving on to the effect of temperature change, a factor that profoundly influences the behavior of matter. Heating a substance increases the kinetic energy of its particles, causing them to move faster and spread around. That's why solids turn into liquids and liquids turn into gas through heating. Conversely, cooling a substance decreases the kinetic energy, resulting in contraction. That's why gas turns into liquid and liquid turns into solid during cooling. This is a fundamental principle with vast implications across various fields of science and engineering. Now let's touch upon the measurement of temperature. Whether we're using Celsius, Fahrenheit, or Kelvin scales, temperature serves as a measure of the average kinetic energy of particles in a substance. It's a crucial parameter that governs numerous physical and chemical processes, providing valuable insights in the behavior of matter under different conditions. Now we know that temperature is measured in Celsius, Fahrenheit, or Kelvin. Kelvin is the SI unit of temperature. Lastly, we'll discuss the boiling point and melting point, two defining properties of substances. The boiling point marks the temperature at which the substance transitions from liquid to the phase of gas. Meanwhile, melting point signifies the transition from solid phase to the liquid phase. These characteristic points not only aid in substance identification but also play a vital role in various industrial and scientific applications. For example, the melting point of ice is a 0 degrees Celsius, whereas the boiling point of water is 100 degrees Celsius. Alright folks, that's it for today. Thank you for watching my video. Like and subscribe.